shut up, kid.
That's on the recording now, though.
There's so many. Now the abuse is proven.
Anyone that watches the videos, like, if they miss a day, they're like, why does Lisa and Kristen and everyone talk so much? That's all I can hear.
At least we're funny. You're not. I am. You're not.
Okay, so today's notes, if you print them off and see them, basically it's a lot of problems. I tried to throw a whole bunch of old diploma questions in, and I figured that was a good use of a day. Basically just walking you through, this is kind of what you're going to be able to solve. I've shown you now 3 main ways of solving questions. The first one is using the fundamental counting principle. That basically just means take some numbers and times them by each other or add them by each other. So if it's something that's an and scenario, times things. If it's an or scenario, add them. That's the fundamental counting principle. Permutations is where there's like 5 pick 3. There's 5 people out there and 3 of them get to make the team, but first, second, and third, there's like different prizes for being first, second, and third. And then yesterday I showed you combinations, which is where it's like 5 choose 3, where if you finish first, second, or third, it really doesn't matter. You're either like on the team or you're not. Does that make sense? And your biggest struggle, guaranteed, is going to be interpreting problems. Like that's what the student's about. It's not, the math isn't hard. Oh, most of the questions to solve them, most of them.
Oh, what's going on?
We chatted with Con for the day.
Oh,
You okay?
I'm fine.
He's like so concerned here. Things you hear about on the lesson. To anybody who listens to some of that. Does anybody actually listen to these? Anybody watch these videos after?
I have.
Okay, good. I'm glad it's worth it. Anyways, whatever I was saying, your biggest struggle is going to be interpretation. It's much less like algebra, where you have to use a lot of crazy mad math skills, like algebra skills. It's more like, and I'm sorry if this is not your thing, but it's probably more like social studies, where you have to take a source, you have to interpret what they're going for. Does that make sense, the analogy I'm trying to give here?
Yeah.
It's an interpretation skill. And sometimes I really struggle as a teacher as to how to teach you it, because sometimes really all I can do is just kind of say, here's the answer and here's why, and hopefully you get it. I felt like yesterday was a good example. We were talking about how many more ways there were to try to get a key to that conversation we're having there. I find it so hard to try to explain, okay, like the wording of how they meant more didn't mean in that example to take the previous set of license plates and the new set of license plates and subtract them, because the old license plate still counted, so you didn't actually need to subtract the old ones. Like that. It's little things like that that are going to be what bug you during this unit. So, long story short, my goal today is to just give you a crap load of questions to try. And sometimes just the best way to get better is to practice. The more scenarios that you're familiar with, the better you'll be. Does that make sense? So, let's give them a try. So, here's 4 questions on a slide where really they're just designed to try to show 4 different ways of maybe solving a question. So, each one of these is like a unique strategy. So here's the first one. You got a pizza parlor. It's got 25 different pizza toppings. How many different pizzas can you make with 4 toppings?
25 choose 4.
Well, let's walk through some options here. So maybe one option would be 25 pick 4. One option could be 25 choose 4. There's another possibility. What if it was 25 times 25 times 25 times 25?
Wouldn't it be just 25 to the 4?
Which would be 25 to the 4?
Wait, can you?
So let's try to figure out which one of these 3 is the right one. Because one of those is the right answer, but we got to figure out which one is correct.
How can you use 25 each time? You can't go 25.
Well, so now we got to consider this. When you make a pizza, it says that it offers different toppings,
You could have double cheese.
and it says you have to have 4 toppings though.
Can you have a true?
So I think what this is implying here is that you actually have to have a different topping every time. Does that make sense? Because otherwise you don't have 4 toppings. You have 3 toppings. You just have extra cheese. Does that make sense?
Yeah.
So based on that, I think this option's out, because that option seems to imply you can use the same topping over and over and over again. Okay. So then the next question we have to ask ourselves then is, does the order in which the toppings go on the pizza matter? Or is the order more irrelevant? Kind of like when I dealt you a hand of cards. Does it matter whether you have the ace first and then the king? When you make your pizza, does it matter that you first put on pineapple, then pepperoni?
No.
I would say that the interpretation here is probably that order doesn't matter. So whatever 25 choose for is, that'll be the right way of putting it. 25 C for.
I'm so proud of myself. Right.
Maybe another way of phrasing that, by the way, would be to say there's 25 total options. 4 of the options make the team, and 21 of the options don't make the team. That's kind of what we just accomplished there. Anybody have a number for me, by the way?
Oh, no. 1062.
12,650.
Well,
Oh, okay.
did I not do that right?
Calculator?
It's
12,650.
I was totally wrong.
Yeah, yours is right here. Okay. So, Keely, do you know where yours went wrong?
Oh, I put 24 in.
Okay.
I'm
Feel
a
good,
stupid
right?
idiot. I'm just kidding.
Okay. Questions on the first one. Does that make sense? Like I said, mostly.
Right number in the calculator.
Okay, mostly interpretation. The first one's okay?
Yeah.
Okay, let's try the next one. You got 6 people standing in a row for a photo. Well, okay, let's write out some possibilities. 6 to the power of 6. Maybe 6 choose 6. Maybe 6 pick 6. Maybe 6 factorial, maybe. Let's just draw a picture here. 1, 2, 3, 4, 5, 6 people in a row. There's not really any restrictions here, so how many people can sit right here?
6.
And then 5, and then 4, 3, 2, 1.
So 6.
6 factorial seems like a great way of phrasing it. By the way, that is the same as 6 pick 6, by the way. 6 pick 6 means that there are 6 people on the team, and the first person is unique. The second person is unique. The third person is unique. And there are 0 people, by the way, who don't make the cut for the photo. But if you divide by a whole bunch of 1s, that's kind of silly, isn't it? So actually, this would have also worked, whatever that is. 720?
Yeah.
Yep.
That's what I got. How did you know that,
Let's
Sean?
not trust you.
I've done enough of these that I memorize a few of them. Okay, so we did a little bit of gambling talk yesterday. Blackjack. So blackjack is like 21. So how many cards in blackjack do you get when you start? 2, yeah.
How did you guys know that?
We did it yesterday.
We played it
We
yesterday.
played a little bit of gambling yesterday.
I didn't.
Okay, so here's maybe the more important question. When I had the whole deck of cards, I gave you 2, but how many were there total in a deck? Alright. So 52, it could be pick 2, it could be 52 to choose 2. It could even be like 52 times 52, maybe 52 squared. So let's walk through different options here. 52 squared would mean the first time I hand you a card, I have 52 cards to give you. And the second time I hand you a card, I have 52 cards to give you.
Lie.
And that's out because as soon as I hand you one of the cards, isn't one of them gone?
Yeah.
So that's it. So then between these two, we got to figure out, does the order matter?
No, not really.
No, I mean, so long as they add up to 21, you win. If you have the ace on top and the king hidden, who cares? So it's choose. Another way of approaching it then would be to say that there are 52 cards in the deck.
Wow, you're winning.
You get 2 of them, and there are 50 in which you did not get them. What the number?
1326.
1326. Sound good? Cool. Okay. Julia's gonna plant some trees. There's 10 trees in a row. Now this one's a bit of a twist. There's a lot of numbers, eh? There's 3
Yeah.
pine, 4 elm, 2, and 1. So I mean, you might be stuck going, okay, well, is it 10 choose 3 plus 10 choose 4 plus 10 choose 2? Like, how does this fit, right? Part of the issue is where do they go together? So maybe the first thing I gotta point out is that when she's planting these trees, is she planting pine trees, or planting elm trees, or planting birch trees?
No, because
No,
she's
she's
equals
planning.
10.
Yeah,
She's planting all of them. So what I just wrote down here is not going to work because it's not an and scenario. It's not an or scenario. It's an and scenario. Really, maybe one way of approaching it is that there are 10 trees right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then she just randomly goes and picks a tree and says, well, you have 10 choices, then 9, then 8, then 7, then 6, 5, 4, 3, 2, 1. That's kind of how you could start this thing. You could say there's 10 factorial ways of planting them. But don't the 3 pine trees look identical?
Yeah.
So if you were to change the order of the 2 pine trees, would you see a difference? No. So I got to divide by the 3 unique pine trees, and divide by the 4 unique elm trees, and divide by the 2 unique birch trees, and the 1 unique willow tree. This is kind of like that question where I give you a whole bunch of different letters, and there's repeated letters. Right. Or it's kind of like the grid scenario, where I give you one of those grids here, and there's like 1, 2, 3, 4, 5, 6, 7, 8. But like 5 of them are over and 3 of them are up. One of those kind of scenarios. Piece of advice though, when you actually find this number, all of these guys need a bracket around on the bottom.
I'm not even done yet.
Okay, it says 12,600. Cool.
Crap, I missed done. Okay.
Alright, so with 4 different questions here, I've shown you 4 different varieties, I guess, of question type. And there's not just 4. My job would be a lot easier, and I think your lives would be a lot easier if I can just be like, hey, look, there's only 4 question possibilities. It's one of these 4. Because there's so many little twists. Like, for example, what if 2 people have to stand next to each other in a photo? What if Brad and Angelina break up and they can't stand next to each other? Yesterday I showed you guys an example of how many ways is it possible for a team to win a 7-game series. And that one was tricky because you could win in 4 games, or, keyword here, win in 5 games, or win in 6, or win in 7. And then you had to put a lot of numbers together. So, practice helps. You get what I'm saying here? So, that's what we're going to do. So, here are basically the 3 formulas you need, by the way. Here at the top is the generic formula where you have the same type of object, divide by the same type of object. Here is the formula for permutations. The number on the bottom, by the way, right here, these are the ones that do not make the team. And here, these are the ones who do not make the team, and these are the ones that do make the team. So those are your basic 3 formulas. Let's try some diploma questions. So these were on old tests. So, first twist. We want to know the number of distinguishable arrangements that can be made from the word kitchen if the vowels have to stay together. So here's twist 1. What if Brad and Angelina are so in love with each other that like they just can't separate? They have to stand next to each other. You guys remember how to solve a question like this? What the method was?
You just treat them as the same.
Treat them as one person. So if I were to write out some letters here, I'd say you have a K, you have a T, you have a C, and an H and an N. And the 2 vowels, I and E, they're so in love with each other that they're really just one person. So how many people do you actually have? Well, you have 6. So if I wanted to arrange them, there's 6 factorial ways of doing that. Except, these 2 guys right here, if you wanted to, you could flip them around and go E and I. They're still next to each other. So therefore I have to times by these 2 guys right here are a 2 factorial because you can flip the 2 of them.
Just give
So
it.
the answer is D. There are 6 items, technically 7, but drop it down to 6 and then times by 2 because there's 2 vowels sticking together. If there were 3 vowels sticking together, you can times by 3 factorial. So, sometimes I've done this example. I'm going to steal some of your stuff if you don't mind. 1, 2, 3, 4. So I have 5 items in front of me on the table here. 1, 2, 3, 4, 5. These ones, they love each other so much, they go together. Here is one way of arranging them. I feel like one of those people that does magic stuff, right? So there were actually 5 items. Now there's 1, 2, 3, 4 items. Flip. Does that make sense? The fact that I can flip how that works means I have to times by 2 factorial. So letting you know that stop. Any questions?
Nope.
Okay, a multiple choice test has 15 questions. let's say I gave you such a test like this, and I went into it telling you 4 of them must be A, 3 must be B, 6 must be C, and 2 have D. I think that'd be really mean as a teacher to tell you how many of each A, B, C, or D you expect. Because like if you didn't have the right A's, B's, C's, and D's, you'd probably freak out a little bit, right? So then my question is, well, how many different ways could you arrange your answers if I told you by the time you're done you better have, 4 A's, 3 B's, which of these fits? As you can see, the question here really isn't about you actually doing any math. You have to interpret which one's best. Any thoughts?
C.
It's C. You're right if you picked C. Yeah, the rationale here is, let's say I wrote out an answer key, and you said A, B, A, C, D, D, C, 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 A, B, B. Anyways, I'm not going to do them all here. Let's say that you flipped this A and that A around. Would you actually see a difference?
No.
No, and these C's right here, aren't they kind of the same as each other as well? So in a way, what you have is there's 15 total letters, but 4 of them are A's, and 3 of them are B's, and 6 of them are C's, and 2 of them are D's. Okay. It literally is the exact example of that formula. Okay. Scenario. Family's going in line for a group photo. Family consists of mom, dad, baby, 5 kids. Make sure you read really carefully. How many people total are there then?
That's a lot of kids.
There's 7.
There's 8.
Yeah, there's 8.
Because there's mom, dad,
But why are they
baby,
including the baby?
and
Is it
5.
just a random baby? Or they
Oh.
baby?
I mean, I guess the baby is not part of the 5 children, I guess, right? But the way they phrased this here, though, it's a baby and 5 more kids. Does that make sense? So, I mean, I know the baby's one of the kids, but the way they phrased it, there's 1, 2, 3, 4, 5, 6, 7, 8 people there. So, well, let's put them in a line. 1, 2, 3, 4, 5, 6, 7, 8. It says that you have to begin and end with a parent. Yeah, I guess that means this one has to be a parent. This one has to be a parent. So I guess, I mean, if you started from left to right, there's 2 choices here. But that kind of by default means that this one right here has to be the other parent, right?
So I think go to
And then kind of what fills in the rest? Well, I mean, there's 6 remaining people, I guess. 5 kids and a baby. I don't know, I guess maybe a baby doesn't count as a child yet. So then 6, 5, 4, 3, 2, and 1. One of these ones is a baby somewhere in there. Apparently it can stand. This is fundamental counting principle, basically. Times a whole bunch of numbers together. 2 choices of parent, 1 choice of parent. Those are the 2 restrictions. And then everything else can be whoever. What'd you get? B.
Yeah, B as well.
1440? Cool. Do you know what I say though when it's interpretation? Alright, like it's social studies. You need to take a source, you need to interpret what it's suggesting. And at that point, I don't mean to say that it's easy, but it's basically just, well, at that point, you're just multiplying numbers together. Right? Okay, scenario. Committee requires 1 accountant, 2 marketing agents, and 4 board members. It goes on to add, okay, there's 4 accountants available, 3 marketing agents available, and 7 board members available. How many committees can you form? There's a lot of numbers there, right? There's a 1, a 2, and a 4, followed by a 4, a 3, and a 7. So if you look at our responses, 3 of them are numbers, and the other one is 14 picks up.
So want to be like 4, 1, stuff like that.
Okay, well, let me start with that. Let's just start with the accountants. Think of it like when we did cards. How many accountants are available? There's 4 accountants available. How many cards are available in a deck? 52, right? How many of these accountants do you need?
1.
Alright, so now for the interpretation. Pick or choose.
Choose because the order doesn't matter.
Yeah, I mean, if you're making a committee, either you're on the committee No, you're not. So choose, I think, is most appropriate. Then you need marketing agents. And it looks like there are 3 marketing agents and you need 2 of them. And hopefully you'd agree it's the same logic, right? I mean, if you're selecting teams here, 2 of the marketing agents make this team and the other one doesn't. So 4 choose 2. And the last one is there's board members. We need 4 of them out of 7. So there's the first bit. I figured out that I need 4 choose 1, 3 choose 2, and 7 choose 4. Can you guys help me out a little bit here with these numbers? What is 4 choose? 4 choose 1 is what? 4, right?
Yeah.
3 choose 2 is 3?
Yeah, it is.
And what's 7 choose 4?
35.
Okay. So if I'm looking at these possible answers here, 4 plus 3 plus 35, I believe it's 42. But 4 times 3 times 35 might be 420. So again, this comes back to interpretation now. Do we need accountants or marketing agents or board members, or do we need accountants and marketing agents and board members? And. So the symbol you might see, by the way, is this upside down looking U. That's the symbol for and, which we'll do more later. But really just times them all together. And so I think you guys told me it was 420 when you times them?
Yeah.
So, moving on. Like I said, we're just doing examples today. Lots and lots of examples. Okay, 6 parking stalls in front of the stores. How many different ways could you park 5 cars there? Sometimes it helps just to even visualize it. So, I don't know, I'm going to put car A right here, car B right here, car C right here, car D right here, and car E right here. Which means that one's empty. Yeah, that's one way I can do it. Let me do another color here. I could do car A right here, car B right here, car C right here, car D right here, and I can put car E in the last stall and leave that one blank. Does that make sense? Well, what if I flipped A and B around? Is that a different way of parking?
Yeah.
Okay. That actually is going to help, because if flipping A and B around is different, it means it's a pick. Does that make sense? So order seems to matter.
So 6 pick 5.
Is correct, yeah, good job. Think of it this way. There are 6 parking stalls available, and we're going to pick 5 of them to get used.
So make 720.
There you go. 6 pick 5 is 720. There are 6 stalls available. 5 of them will get used. The order seems to be relevant, because if I flip the Honda with the, I don't know, Lamborghini, that makes a difference.
Goes to Honda to Lamborghini.
But it makes a difference in terms of orders, right? So 6 pick 5. You guys get what I mean though when I'm saying that some of these questions you're just going to look at them, and all you have to do is just, here's the answer. Okay, this is one of the more challenging questions. So, scenario, again, think social studies. Here's a source. We got to interpret the source correctly. There's one bag, there's 4 colored marbles. There's another bag, also 4 marbles, and none of these marbles are the same color in this. So here's the scenario. A person reaches into the first bag and pulls out 2 marbles. A person also reaches into the second bag and pulls out 2 marbles. How many different color combos are possible?
Well, wouldn't you do like 8 choose 2, 4 choose 2, 4 choose 2 or something?
That's correct, actually. Good job. Yeah, let's see if I can illustrate why. The correct answer is there were 4 models that you had, and you chose 2 of them. Why choose not pick?
Because it doesn't matter the order.
Yeah, if I reach into the bag and I first grab red and then I grab blue, at the end of the day, don't I have a red and a blue marble? Or a blue and a red marble? Does it really matter? But then I have to times because I'm also reaching into the second bag, and in the second bag there's 4 marbles and I need 2 of them. Is that what 4 choose 2 4 choose 2 is?
Yeah, do you have to do brackets or anything?
Your calculator, you know BEDMAS works, your calculator will force this thing and this thing to always happen before the time sign, but it's never a bad idea to put brackets around things. But you technically don't need to. If I could, can I show you one of the common distractors? some people might think, well, there's 8 marbles, and I chose 4 of them. Try 8, choose 4.
That's
8 choose 4 is 70. Why does 8 choose 4 not work?
Because bags are individual. They're different colors.
So 8 choose 4 could imply that I could take all 4 marbles out of the first bag. Does that make sense? But that's not how the rules work. The rules say only 2 from the first bag, only 2 from the second bag. 8 choose 4 basically means dump all the bags together and then pick out 4. And that means that, like, for example, if you had red, orange, yellow, and green, blue, violet, indigo, and turquoise, under this scenario, you could have these 2 and these 2, but under the other scenario, you could actually have picked all 4 of these. That's not allowed. Does that make sense? Okay, at a business meeting, every person shakes every other person's hand once. There are 91 handshakes in total. How many people were at this meeting? Now, this is a bit of an oddball question. I always make sure to show both my -1 and -2 classes this question in case it comes up. Because this one's frustrating because if I ask you what numbers you have to work with, you'd say, I have the number 91. But isn't it usually like 91 choose something?
You just lost your very big glasses. They're black with blue arms.
Not a bad idea, but unfortunately that's not probably the right one. Okay, let's try the scenario here. Just even to map it out here. I'm going to shake your hand. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I've shaken everybody's hand, so that's 11, right? Now, Tate's turn to go around and shake hands. Who does Tate not need to shake hands with?
You.
Me. Because he's already shaken hands with me, right? So if I shook hands with...
So that means like 91, like everyone shook a different person's hand, so everyone.
So there's a lot of handshakes now, right? Because he's now shaking, you've shaken 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, both of us are done shaking hands.
So
She doesn't need to shake our hands anymore, but she still needs to shake yours.
So what's the opposite of factorial?
So it's kind of like that. It's almost backwards. So let me show you the best way of approaching this is when you shake someone's hand, how many people are required for a handshake?
Everyone except
2.
yourself.
Individually, in order to achieve a handshake, you need 2 people. That's actually the twist here, is if they ever give you a handshake question, it implies 2 people. Does that make sense? What this really means is that something chosen 2 at a time gives you 91 handshakes. That's actually how this question gets solved. We don't know how many people there are. So it's kind of like the deck of cards question. I don't know how many cards are in the deck, but if I choose them 2 at a time to shake hands, there will be 91 different combinations. Now, this one's challenging because then how do you work backwards? The best way of doing it is just guess and check. 14 choose 2, 15 choose 2, 24 choose 2.
Yeah. It's 14.
14 choose 2? Okay. This is a very unique question. It's the handshake question. So if you ever get a handshake question, what you need to do is you need to do an unknown number, choose. By the way, the reason why it's choose is that does it matter who initiates the handshake between me and Tate? If I start the handshake with Tate, or if he starts the handshake with me, it doesn't really matter who's first and who's second. No. So that's why it's a choose. So people get chosen 2 at a time to shake hands, and there's 91 total. By the way, I should point out another common question along these lines involves sports. When I think of a question like this, I think of how like Patton maybe would, in the gym, set up like a bracket for playing badminton. Okay. How many people play badminton at a time? Let's say 2, just singles tournament, right? He might say, I need to schedule 91 games of badminton. We need people 2 at a time on the court. So then something choose 2 equals 91. How many players are in the gym? Apparently 14 players. Chosen to play a game where 2 people play a game means he needs enough time for 91 games. See how that works? It's kind of the same concept. Okay, this is my favorite question. You need to take a second to like truly appreciate the video game titles I came up with here. A used video game store has the following titles available for purchase. Legally owned auto.
So
Come on, that's awesome. Crypt Infiltrator, Angelic Circle 3, Warfield 2, Final Quest, Old Scrolls,
Old school.
Never Autumn Days, Minor League
Dot
Baseball.
Gobbler.
Definitely. Punky the Porcupine for Sonic, Falling Blocks, Tetris. It's clever, isn't it? Anyways, okay, so here's the scenario here. A customer is going to purchase 3 action games, 1 role-playing game, 2 sports, and 1 classic. How many different ways can you purchase the games? So let's talk for a second here about pick versus choose scenarios here. Is it possible for him to buy legally owned auto and then buy legally owned auto again?
No. He couldn't, but that'd be a waste of money.
Yeah, okay, so would common sense not dictate that once he buys a certain game, it's probably not buying a single choice, right? So that means it's not like 4 times 4 times 4 times 4 times 3 times 3 times 3, right? So it means it's pick or choose. So now that we know that it's pick or choose, does the order matter? Like if he goes to the shelf and first buys legally owned auto and then buys Crypt, or first he buys Crypt and then legally owned auto, does it really matter which order it happens in? At the end of the day, doesn't he either own a game or he doesn't own it?
Yeah.
Okay. So in a way, there are 4 available action games, and he's going to choose 3 of them. And there are 3 available role-playing games. RPG is role-playing game, right? Okay. And Panini's one. And there's 2 sports games. It looks like he's taken both of them. And there's 3 classic games, and he owns one of them. Yeah, that kind of gets us started here. Final question, what goes in between all these things? Pluses or houses? Why multiply?
Because he
and
Yeah, I mean, maybe it's just one little word, but he needs to buy these ones as well as, and. So I'm going to guess that 4 choose 3. Like, you can probably type this all in at once if you want. 4 choose 3 is probably 4. 3 choose 1 is 3. There's only one way to do 2 choose 2, and that's probably 3. I wouldn't expect you guys to be able to do that. I've memorized a few of these numbers. I'm going to guess then that it's 36.
G.
Did that make sense?
Smart. Yeah.
This is a classic question. They almost always seem to ask something like this, where they give you a grid, and it's a whole bunch of chooses, and you just multiply them together. Making sense?
Yeah.
Useful class time on this though?
Yeah.
Okay.
I like it.
Okay. Like I said, I mean, this section really is, I'm just going to beat you over the head with lots of examples. It's one of the best ways of doing this, I think. Okay, research team's got 6 people. And we need 10 chemists, 5 politicians, 8 economists, 15 biologists. But there's one stipulation now. The stipulations are the worst. Because it says you have to have at least 5 chemists. There's 2 little words in here that make all the difference. And those words are at least. Because at least implies that you could have 5 chemists.
Also 6.
And I'm going to add another word to what you just said there. You could have 5 chemists, or
6.
you could also have 6.
7.
Make sense? So at its core, this question is an or question, where you could have 5 chemists and 1 random person, or you could have 6 chemists. Chemists are pretty awesome, by the way. And I guess if you have 6 chemists, there's no room left for anybody else, isn't there?
Well, dang.
Do you see how those kind of fit together like that? So you could have 5 chemists and 1, I don't care what they are, or you could have 6 chemists. So let's try them. How many chemists are there total? Well, there's 10 chemists total. And if we put them on a team, does order matter?
No.
So choose. We need 5 of them. What if you pick 1 more random person?
So you have to count them all together, including the chemists.
Well, okay, so that's a good question. We've already selected some chemists, so we can't count those chemists again,
Oh,
right?
it'd be like 5.
So how many people are left then? There are 5 chemists left, 5 politicians, 8 and 15. So if I add those together, that's 20, 33. But here's the problem though. Hypothetically, let's say that we pick another chemist. doesn't that mean that that would fall under the 6th chemist branch? So I have to make sure I'm very specific. If I pick 5 chemists, this random person cannot be a chemist. Because if that person is a chemist, then that would fall under the 6 chemists category. Well, so then ignore the chemist entirely. What is 5 plus 8 plus 15?
28.
Okay, so then there are 28 other people left over, and we need 1 of them. And I said a really key word in there. I said 28 other people, and we need 1 of them.
And then if he chose 6 chemists, that's the other one.
Okay, well let's do that one now then. Okay, so then let's say we do 6 chemists. Well, how many chemists are there available?
5.
Well, there's 10 chemists available, right? Because this is a new scenario, right? This is the scenario where you pick the 5 chemists for 1 random person.
Okay.
Or hypothetically, let's say you didn't do that scenario. Let's say you did 6 chemists. It's 10, and we need 6 of them.
Okay.
In theory, you could say that there's 28 other people, and you're choosing 0 of them. By the way. But 28 choose 0 if you do it in your calculator is 1. So you can kind of skip that. Let me talk through it from the top then. 10 chemists, we want 5 of them. 28 people who are not a chemist, because it cannot be another chemist. We want the 1 random leftover person. Or you could just have 10 people and 10 chemists, and we'll just choose all 6 of them from chemistry.
I got C. That's kind of confusing, but I got it.
It is, isn't it?
Yeah.
It's one of those things where I feel like I need to show you this one, and then hopefully the next time you see this scenario, you're like, oh yeah, we did one like that. Right? And the more you practice it, you'll be like, okay, I have a little bit of experience solving this puzzle. Because that's what you got to treat this like. These are puzzles. It's more of a brain teaser than a math problem. I mean, it uses math skills, obviously, right? But it's not algebra math. It's not solve for x. It's use your, I hate to say it, but use your common sense. Use your brain. Any questions? How many more do I have? Let's start with that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Holy smokes, okay. 2 more and then a break?
Yeah.
Is that fair?
Deal.
Okay. Okay, well, we just did a bunch of committee work. This one here says that there are 6 men and 9 women available for a 6-person committee. This is really similar to what we just did. It says that the committee must have at least 1 man. How many committees are possible? Okay, so where do we start if it says you have to have at least 1 man?
That means there could be 6 men.
Okay, so let's start at the top. You could have 6 men and no women. Very sexist. You could have 5 men, and I guess by default 1 woman. You could have 4 men and 2 women. I'll have to go way down here now. You could have 3 men and 3 women. Very Justin Trudeau. 2 men and 4 women. And you could have 1 man and 5 women. But apparently the one thing we can't do is have 0 men with 6 women. The other reverse sexism one. This sucks. I got a lot of work to do, don't we? Okay, so let's give it a try here. 6 men. How many men are available? Well, there's 6 men. And we need all 6. It's a committee though, right? Order doesn't matter. 6 choose 6. Honestly, I'm going to skip the 0 women part because we're not selecting any apparently. Or you could do 6 men and choose 5 of them. 6 men, choose 5 of them. And you need to pick 1 other woman. So there's 9 women left over. And you're choosing 1 of them. Or, well, once you do a few of these, you get the pattern here. There's, again, 6 men, and you need 4 of them. And there's 9 women. You need 2 of them.
Is there a faster way to do this?
Sadly, no. I gotta be honest though. Compare this to the algebra we did here. I know this is a lot of work, but this is still 2 minutes and under, isn't it? Fair enough. Fair enough. Okay, well then there's 6 men and we need 3 of them, and there's 6 women and we need not 6. 9 women, and we need 3 of them. Okay, you know what? I'm picking up a pattern here. The first number is always 6 and 9, and 6 and 9, and it's always a choose. Okay, this time it's 6
Can we
choose
just add them all
2.
together and do that?
By the time we're done, we're adding them all together, yeah.
Why can't we just go 6, 12, just time all those together and then add all those numbers together?
I don't think that's how BEDMAS works though, because this is how many combinations there are here, plus whatever this combinations are, plus what this combinations are. So, I mean, I know it's a little bit of work here, but hopefully you agree. Like, we need to make sure we're methodical. Don't make a mistake for something silly just because you're, just because you want to speed things up. So, Tate, I'm gonna steer it down here if you don't mind. Okay, so 6. No, that's not right. 6. Choose 6. So I got 6 choose 6 gives me 1.
Yeah.
1.
And then 6. Choose 5 times 9. So this one I have as being 54. This one I have as being 540. This one I got 1680. This one I have as being 1890. And this one I have as being 756.
Ooh, I made a mistake. It didn't let me do it.
It's deep.
Oh,
I got 4921.
Wait, let me do
Let's
that.
do that.
Okay, so hopefully you guys would agree. I say this a lot. The math, not hard. You gotta type a bunch of buttons in your calculator. So long as you're capable of doing pluses and minuses, you're golden. This question kind of sucks because it's a lot of work. But, I mean, I don't really have a great answer to that. If you're really doing work, you're gonna have a hard life. Okay, let's do one more. Take a break after that.
Oh my goodness.
Okay, so for this particular question, guys, give me 1 more minute, okay? This one's a short one. We'll take a break here. This one is just like one of the ones we already did before. There's 6 A's, 8 B's, 10 C's, and 10 D's. Holy smokes. Whoa. Go some math questions.
Rylan did it.
We're going to divide by 6 unique A's, divide by 8 unique B's, divide by 10 C's, and 9 D's. Does that make sense? What number goes on top?
Whatever that is.
The total.
Whatever the test, whatever 6 plus 8 plus 10 plus 9 is. Let's see, that'll be 27, 30, 33.
33.
I was close.
It's a lot of different answer keys, obviously. You just need to know how your calculator works. Let me know as soon as one of you gets an answer here. Don't forget, by the way, brackets around those factorials there.
Why do you have to think you're going to write a math? 2.27 times 10 to the power of 17. Well, yep, that's what I got.
Moodling.
Yes, I got something right.
Alright, take 5 minutes and we'll come back to some.
This message is for teachers. If you picked up photocopying in the photocopy room from the black printer, can you please check your stack of photocopying? There is an assessment for the kindergarten group in there. If you signed it, please bring it to the
Why
office.
didn't you just print the other one?
I wonder whether there's like a legally formed kind of thing though, whether it's for a, you know what I mean, like where I shouldn't have a copy of it, maybe because it's for a little kid. I don't know. I don't have it, so it's not me. Okay, let's do this example here. You're trying to arrange produce in the grocery store aisle. And basically it says you can arrange the items in any order, but here's the restriction. Okay. Pumpkins and watermelon are not together. So we haven't done one of these yet today. We've done one before. This is the Brad and Angelina question where,
The 2 parents are going to be on the end or something.
well, not just on the end of each other. That's possible. They just cannot be next to each other. Does anybody recall the method as to how you solve the Brad and Angelina breakup question?
And you go factorial divided by 2 factorial? No?
No.
I have no idea.
You skipped it, got a 0 on that question.
Okay.
You just circle around.
Okay, let me remind you then.
It's fine. I'm just kidding.
Where's tapping? Tapping?
Devin! It's always Devin.
Shut
Okay.
up.
So here's how you solve the broken up can't be next to each other question. There's a total number of ways without restrictions, right? If you subtract the number of ways in which they are next to each other, wouldn't that leave the ones in which they are not? Guys, focus, please. Break was bad. Good. The way you solve this question, you find the total number of ways without restrictions that you can arrange things. That's easy in this case. That's 5 factorial. 5 times 4 times 3 times 2 times 1. That's how many ways you can arrange products with no restrictions. But the ways in which they are next to each other would be 4 factorial times 2 factorial. Because we already did that example where there's actually not 5 items. There's 4 of them because the pumpkins and watermelons are the same thing, times by 2. If you find the total and subtract the ways in which they are next to each other, that should leave you logically with the ones in which they are not next to each other.
So 72. Yeah.
Are you timing it or minusing?
Sorry, that's a minus. Okay. So one more time, listening carefully. Okay. If you want to find the solution to the Brangelina breakup question, where people cannot be next to each other, it's actually, first you have to solve the ways in which they are next to each other. So that's 4 factorial times 2 factorial. Rather than there being 5 people, these two are stuck together, so there's actually 1, 2, 3, 4 people.
Oh, that makes sense.
But you can flip the 2 of them, so that's why it's 4 factorial times 2 factorial. Those are the ways in which they are next to each other. Well, if you take the total possibilities with no restrictions and subtract the ways in which they are, doesn't that by default leave the ways in which they are not? So 5 factorial ways in which there's no restrictions, subtract the 4 2 factorials, should leave you with 72 remaining ways. Okay. Once you've seen a question where they're not next to each other, I mean, it's very easy to solve. You just remember the method, that's all. Devin, could you do me a favor? Describe the hallway door there. Okay, let's move on. All the letters in the word pencils are used. We need all of the vowels together. We kind of did one like this, didn't we?
Oh, there's only 2.
We did one like almost exactly like this. How many letters in the word pencils?
7, but you need just 6.
So drop it down to 6 letters. And the 2 vowels are next to each other. There's only 2 of them, so 6 factorial times 2.
Times 2 factorial or just
Technically 2 factorial. Sometimes I skip the factorial on this particular example because 2 factorial is 2 times 1. And 2 times 1 is just 2. 14, 40?
Yeah. Yeah. I got that too.
Sounds good. Moving on. Okay, sometimes you get a question where they'll ask you about, like, numbers. For example, these ones here, you want to do 3-digit numbers and 4-digit numbers, but they're being very specific. It has to be an even number.
Oh, 7 can be at the end or 3.
Yeah, the way an even number works then is that maybe a better way of approaching it is an even number has to end with a 2, 4, 6, 8, or 0. Does that make sense? That's what makes something an even number. An even number is divisible by 2. So, like, for example, is 235 even? No. But would 536 be even? Sure. As soon as I said the 6 at the end, then it's even. There's a bolded word here, though.
Or.
So first I'm going to do 3-digit numbers. Then I'm going to do 4-digit numbers. Well, the stipulation here, though, is that it has to be even. So how many even numbers do I have available for the last digit? 2 and 6.
So 2.
So I have 2 choices here. Now, this particular question is not one of my favorites here because I'm trying to think about whether or not I should be allowed to use that number again a second time. And I don't see any reason why I shouldn't. You know what I mean? Because, like, isn't the number 636 an even number that's formed from these numbers? So based on that logic, I feel like then there's 5 choices for those because I could use any number for the first one, but the last one has to be 2 or 6. Right?
So then it's the same thing when it says 5.
Same thing for the next one. 5 choices, 5 choices, 5 choices, but the last one has to be 2 or 6. I'm a little worried here.
I didn't get any of the numbers.
No, I'm a little worried here because based on the logic I have here, this right here, well, what did you get when you were done?
300.
300, yeah.
And it's not in there.
Okay, so if you come across a question like this, I sincerely hope they don't do this on the diploma, because obviously they did, and that's kind of cruel. But it seems to imply to me that maybe what they were going for is that once you use one of these numbers, you can't use it again. So that means,
still don't get the same number.
well, not 5 times 4 times 2, because there are 2 choices right here. Whichever number you use here is out of the running. So then there's not actually 5 choices here. There's 4 times choices here and 3 choices here, because whichever number you picked here kind of takes priority.
So that would make that 3 and then 2.
So would it apply to the second set of numbers though?
Yeah, like this one over here's got the same thing then, right? So first you pick the last number. So you've used one of those. Then there's 4 remaining numbers for this, 3 remaining numbers for that, and 2 for that one. Let's see what that one gives us one of the 4 answers.
It does give you 72.
Gives you 72.
Oh wait, no, I got a different one. Oh yeah. I got the same.
72?
Yeah.
So I think that's a good talking point question. It's possible that, and I'm not a big fan of this, but I have no control, just so you guys don't shoot the messenger, okay? But it is possible that they may not be overly specific on a question. This one here, my first interpretation was, hey, why not? I should be able to reuse a number. But once I discovered that numbers didn't seem to give me one of the 4 answers, maybe I interpreted it wrong. Maybe they meant for it to be that once you use the number 3, you can't use the 3 again. So try both combinations. It's like social studies in that there's maybe a right answer and there's like a more right answer.
It'd be even more mean if that was numerical response.
Yeah. Ideally, like we as teachers get to look over the test. So if we see a discrepancy like that, we can kind of argue and say, hey, we need to throw that question out. So, well, just that question. Not the whole diploma. Everybody passes the diploma. One question was off. Okay, a while ago, I gave you guys the assignment, and I appreciate that he tried, but Forrester helped you on a question that's the exact same as this one, only rather than it being a bunch of activities, it was about how many toppings on a hamburger there was. We talked about that one yesterday. You guys remember the question? Because this is the exact same question as the hamburger question. You could select no activities, you could select one activity, you could select all of the activities. But in a fancy way, the answer to this question is you have 2 choices. You could say yes or no to liking mountain climbing. You could say yes or no to liking canoeing.
Oh.
You could say yes or no to liking video games. You could say yes or no, yes or no, yes or no, yes or no. So the answer to this is 2 to the 7.
C.
Yeah. Does that make sense? Sometimes, and I think like not Forrester's brain, I don't know what he was going for at the time, but I think sometimes you get so caught up sometimes in picking and choosing that sometimes you forget that it is possible just to go back to good old this times this times this times this times this stuff. Sometimes you forget about that because that's a really, I don't mean to be mean, but it's a very simple type of question, eh? What's that? We're not done yet, or we are done? Okay, here's a good challenging question. This one is, yeah, I don't expect that you guys are going to get this question, to be honest. This is actually off my Dash 1 class. But I've said this before, I want to make sure that I prep you for anything I could think of. So although I don't expect you might get asked this question, it's definitely something my Dash 1s were asked.
Oh my god.
So I want to show you this particular one. It says that A choose 3 is equivalent to which of the following? If you get a question like this, the best way of doing it is just make up a number for A. So someone give me a number for A.
2.
6 is good. 2 is actually not.
Oh.
There's a reason why. Is it possible to have 2 things and choose 3 of them?
No.
So let's go with 6. So give me help
I
here.
thought it was a run.
What is 6 choose 3?
6 choose 3.
Yeah.
1 second, I'll tell you.
It's 20. 20.
Cool. Okay. So now that we've randomly chosen 6 to be A, let's try that same thing on all 4 answers here. Let's do 6. Choose whatever 3 minus 6 is. Okay, hang on. Let's pause for a second here. What is 3 minus 6?
-3.
Can I give you 6 apples and say choose negative 3 of them?
No.
Okay. That's not even possible. Okay, right here, I could do 6 minus 3. Well, isn't
Oh,
6
that
minus
doesn't work.
3
3.
3? 3 choose 3 is 1, I think, so that's not it. How about 3 choose 6? Well,
0.
Now, the reason why your calculator says 0, though, is because it's impossible. I can't give you 3 people and say choose 6 of them.
That was right.
Well, let's talk about the last one. Let's do 6 choose 6 minus 3. Isn't 6 minus 3 just 3?
Why did I get -2 then?
I was
I got
right. Oh my goodness.
I got mine.
Okay, what you probably did was you did 6 choose 6 minus 3.
Yeah.
But you're actually going to have to put that little bit in a bracket. Because what your calculator thought to do was 6 choose 6,
And then
which was
-3.
1, and then
Okay.
minus 3.
That makes sense.
So I want to show you this question on the off chance you get asked it, because I'm not expecting it. But again, I think it's my job to try to cover all the bases. So in case it happens now, you've seen something like it. Okay, 12 people lined up for a movie. Crystal, Steve, and Jason are having to stand together. It's kind of like Brangelina, only the twist is there's 3 of them stuck together. Thoughts? Which one of these answers fits that best? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3 of them get stuck together. Well, there's now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 objects. But this object right here, there's 3 of them inside it. And they can arrange themselves. They can go anywhere they want. So there are 10 factorial objects. But inside one of those objects, those 3 people can flip themselves around in 3 factorial ways. So the answers would be.
Yes.
So that works?
Oh yeah. Oh, yes.
Okay. Security code used to consist of 2 odd digits, followed by 4 even digits. I'm just going to stop there and figure that out. How many odd digits are there? I think there's 5 odd, 5 even, right? So these are odd. These are even. But you know what? Either way. Okay, now it's actually very specific here. It says repeated digits are allowed. So that means there's 5 possible odd digits, and then still 5 possible odd digits, followed by 5 even, and still 5 even, and still 5 even. Okay, I'm getting a little bored here. That's 5 to the 6 then. Okay, but then it says to allow more codes to be generated, a new system uses 2 even digits, followed by any 3 digits. So 5, 5, and then 10, 10, 10. Alright, now we gotta read this really carefully and interpret how we do this properly. Now we want to know the increase in possible numbers of codes. Okay, so first, someone help me out. What's 5 to the 6?
It's 15625.
50,625.
155.
That number?
Yeah.
Okay, and then this one here is probably going to be 25,000.
Yeah.
Okay, so now this is kind of like that question we did yesterday, which was really confusing about the what was the postal codes. So this is how many old passwords there are, and this is now a brand new system. And the way they phrase this, at least the way I'm interpreting it, is that we're no longer using the old passwords. Does that make sense? Unlike the license plates, where currently you can still have the old license plates on your car, here the old system is out of commission. So now we want to know how many more possible codes are there compared to what there used to be.
9,300.
Okay, so this time we will subtract them to get 9,375.
So that's like what I did wrong. Yes.
This is what you were doing yesterday. The only reason why you were off is that on the license plates, the old license plates are still valid. Which is why we don't need to do the subtracting thing, because the old ones still exist. Does that make sense? But here, the way I'm interpreting this question here, it's a brand new system. So the old codes are out. Okay, I've actually alluded to this question already. This is like the handshake question. Okay. There are 12 teams in a soccer league, and they play each other twice in a tournament.
Oh my.
Anyone want to try to take a stab at which one of these four answers it is?
C.
No.
B.
No.
B.
That's just
D.
D.
Oh.
Okay, so we should talk about this one. Let's talk. Okay, so it's like the handshake question. Let's say that I'm a team and Shodi's a team, and this is soccer. Okay? If I play Shodi's team or Shodi plays my team, does it really make a difference? At the end of the day, wouldn't you hopefully agree that we're playing each other, right? So that's why pick is out, because order is really not relevant when you're playing a game. Technically, there's like a home and an away team, I guess, but I mean, in terms of how many games you need to schedule, as like Pat being the scheduler, if Emmanuel Christian is playing LCI, that's one game. That makes sense? So, but it then says they play each other twice. So that's why we've doubled the whole thing.
That makes sense.
So there are 12 teams. We need to choose them 2 at a time to play. Order doesn't really matter because either you're playing or you're on the sidelines watching. But times 2 because there's choice. Does that make sense?
Oh.
That's a very typical question where the issue is not the math. The issue is the interpreting, the logic, yeah. I wish I had a pill where I could just be like, here, take the pill. You'd be really good at logic.
I've been taking like
I think there was a movie about that. That was Limitless, wasn't it? You ever see that one?
no.
Bradley Cooper, Limitless, where he takes the pill and then like his brain works better.
Have you seen Lucy?
No, I haven't actually.
It's really good.
I think it's a similar concept.
Yeah, it's really good.
Okay, 10 people available for a committee consisting of 6 people. Kirsten and James must be on the committee. Actually, this is a common scenario that I like to use an analogy to everyday life. Anybody ever tried out for a team? A sports team specifically, and you know there's 6 available spots. However, the coach's kid is trying out,
They always make it.
and the coach's kid is gonna make it, right?
Obviously.
So even though there's room for 6 kids on the team,
There's actually
realistically there's only room for 5. Does that make sense? That's what the scenario is like. Yes, it's a 6-person committee, but if James and Kirsten are already on the committee, there's not 6 spots available.
There's 4.
There's 4 spots available.
That's just.
And there's not 10 people competing, there's
choose
8
4.
people competing. So that's why the answer is 8 choose 4. Does that make sense? Because 2 of the people that are really not trying out, they're already on the team. Their dad coaches the team, so they're getting on the soccer team. Does that make sense? So there's 8 kids competing for 4 spots, not 10 kids competing for 6 spots. Does that make sense?
Yeah.
You probably have been in one of those scenarios before, seen those before, right? You know what I'm talking about? Alright. Okay, this is another one of the ones that, this really is off of my Dash 1 class, but again, I want to show you the question in case you're, in case this comes up. So here's the scenario. You're playing Scrabble, I guess, and there's 20 tiles in the bag. and I'm going to ask you to reach into the bag and pull out 3 tiles. We can actually solve that, can't we? If there's 20 tiles in the bag and you reach in to pull 3, does it really matter in which order you pull the tiles out? So someone help me out here. What's 20 choose 3?
1 second. Hurry, go. 1,140.
Remember?
No.
Okay, so that's what the first sentence says. The number of ways that 3 tiles can be pulled out of a bag containing 20 tiles is the same as the number of ways K tiles can be pulled out of 20 tiles. What it's really saying here then is, say you have 20, and I ask you to choose a different number, it also has to equal 1140. That's what this question says. 20 choose 3 is 1140. 20 choose what other number is also 1140. Now, you could just guess and check every single number.
Mm-hmm.
Well, it's got to be a different number than 3, though. Right? Because 3 is already the first one, right? So, the answer is 17.
What? How do you know that?
Okay, so let's talk about team stuff again here. There's 20 kids trying out, and 3 of them make the team. Doesn't that mean that 17 of them don't make the team? Well, isn't that going to be the exact same as saying there's 20 kids and 17 of them don't make the team, so then 3 do make the team? You kind of see how that kind of fits together there?
Yeah.
Whenever you've got the on the team, off the team scenarios, these 2 numbers right here kind of add to give the total. So here, 3 people are on the team. Here, there's 17 that aren't. Because essentially what your calculator did for math is it did 20 over 3 and 17. And isn't that the exact same as 20 over 17 and 3?
Yeah. That's smart.
Yeah. Again, this is actually technically this is off my dash one class. But I wanted to show it to you in case. Okay. So. Okay. Committee time again. There are 10 men. We need 4 of them. We need 13 women. We need 5 of them.
Wait, what?
There are 10 men. We need 4.
Oh.
13 women. We need 5. Which one of these fits best?
10 choose 4.
Yeah.
Plus or times 10?
Times because you need and. So look, there it is, right at the top of the day. After doing, an hour's worth of these questions, I feel like you're probably getting better at this.
Yeah.
Okay, I'm done.
Yeah.
Okay, so quick summary here. There's 3 main topics we've covered. Fundamental counting principle, can you add and multiply numbers together, knowing the and or type thing. Permutations, does order matter? Combinations, does order not matter? Your job, you're a problem solver, you're a puzzle solver. You got to interpret the scenario, figure out what it's asking you. Most of the time, I'd say 9 times out of 10, it's actually a really simple question. Once in a while on the assignment, I've got a few that require a little bit more work, but most of them really are a very basic question. Can I do one more example with you guys?
Yeah.
You don't have a slide for this, but it's so topical right now, and maybe if this really applies to some of you who really are interested. So, well, anybody have one of these?
No.
You don't know what this is? Oh yeah.
My grandma does these.
Okay, so if you're not aware of what this is right now, it's very now, which is why I made a slide for it. It's March Madness coming up right now. If you don't know what March Madness is, it's a big NCAA basketball tournament. Takes over, you know what I'm talking about, right? You make a bracket?
Yeah.
You're going to? Okay, so there's a story behind the brackets like this. Basically what people will do is, this is the tournament. So Kansas is going to play Austin something, Peg, and the winner moves on, and the winner moves on. And eventually, you get to the point where 2 teams play in the finals, and there's a winner. Does that make sense? And what people try to do is they try to pick the winner by selecting the winner of every game. So they'd say, well, I think Kansas is going to win, I think Colorado's going to win, I think Oregon's going to win. And you kind of select your winners all the way through. Anybody, who's seen these?
I've seen them in tournaments.
I did it for the dunk competition.
Okay. So basically the concept then is that people try to do it for money or for pride to see who they think is gonna try to have the best bracket. There was a billionaire a couple of years ago. His name was Warren Buffett.
Yeah.
Warren Buffett offered someone $1 billion if they could have the perfect bracket. What he meant by that is you didn't just get the winner right, but you picked every single game in the entire tournament correct. Every single one of them.
Isn't that score as well?
What was that?
Isn't
No,
this-
he offered the $1 billion if someone got just every single one of them. Okay, like not even like the number score. So like, for example, Oklahoma Bakersfield, if I pick Oklahoma to win, that's great if they win. If VCU, like if Oregon beats VCU and I get that right, that's great. But then if I get like the wrong one on the next one, I don't win the bracket. Does that make sense? Well, what I wanted to talk you through is the odds, the probability of actually winning his $1 billion.
It's so hard.
No. Okay, because here's the odds behind it. This is kind of like the hamburger question. You're being asked one of two choices, yes or no, for who wins here. So you have two choices here. 2 times 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 2. Just so you're aware, in the NCAA tournament, there are 63 total games. For you to win Warren Buffett's $1 billion challenge, you would have to do 2 to the power of 63.
That's it?
Well, let's see how big 2 to the power of 63 is.
Well, if he has a bunch of people doing it, there's going to be more than one person winning.
2 to the power of 63 is this number here.
9.2.
Just for some reference here.
What does the E mean again?
Okay, so that's actually what I want to talk about. I might have room on the board here. So this is 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 18. There. That's how big that number is. The E18 basically means take this decimal point and slide it over 18 numbers. There is one. You guys remember talking about the lottery yesterday? There's one winning ticket in 14 million. There is one way to do this right in,
Oh my goodness.
I don't even know how big this number is. This would be the hundreds, thousands, millions, billions, or billions,
Trillions.
trillions,
Gazillions.
gazillions, 9 quadrillions. Like, the number is staggering. If everybody in the world filled out like 30 brackets, I still don't think he'd have to pay the money out.
And it's so hard to guess it
Hasn't it
because
been
like,
done once?
there's so many upsets.
No,
in the
I
tournament.
mean, there's been a couple where like they're close-ish, but like to guess all 63 games right is just staggering.
Like if you did your research and like looked at their standings.
Yeah, but there's always upsets.
Yeah.
Exactly,
There's
right?
always
Someone,
upsets.
like, fumbles the ball and no one expected it.
Exactly, right? I mean, the odds of this happening are just so ridiculous that, I mean, every year there's usually somebody with like a Cinderella team, like a 10 seed or a 9 seed that goes through, right? And usually there's only like 4 people left in the world who actually have that 4 seed in their bracket. You know what I mean? For like the final 4. But even then, even if they're right about the 4 seed getting there, let's say that they're wrong about one of the games over here. It doesn't matter because this team over here ended up making it there. Any one of the games you get wrong, still your bracket's ineligible for Buffett's $1 billion. So, anyways, if you want to give it a try.
How long was this?
What was that?
When the offer
I think he started doing it in about 2012.
still doing it?
I don't know whether it's still valid or not, but yeah. Okay. Work day tomorrow, work day Thursday, Friday's a quiz, guys.
Nice job.
Yeah, for sure. Let me just stop the recording here.
Oh yeah.
It's already